Office hours tomorrow, 8:30 to 9:30, and I have to leave absolutely at 9:30 because I have a memorial service to go to. So they will promptly end at 9:30. But I'll have regular office hours on Wednesday, 8:30 to 9:30 as well. And here's what I decided to do today. Today and Tuesday. So I'm still a bit concerned about the midterm. I think what I can do today is I think I can condense into, we finished a little early on yesterday, or Tuesday. I think I can condense what I was going to do on Tuesday even more, and hopefully put it all in today. And that way we can have like a review question and answer session on Tuesday. But I'm not going to come in and review stuff. You have to, that means you have to study early, and you have to come in with questions. So if I come in at Tuesday at 2:10 and nobody has a question, then that means that I get to go ride my bike. Okay? So you have to come in. So hopefully, I may spill over a little bit, but I'm going to try to get most things done today. So what I reorganized is, I think it will be a good review, and a good way to introduce this part of the course, is to try to put everything all together. So I used to do this actually on the very last day of class. But I'm going to try to put everything together today. And the reason I think it might work better is because after we put everything together, we have to tear everything apart. So basically all of those arrows and all of those syntheses and all of those negative feedback and things that have to be coordinated in order to get you where you are now, once you hit about 40, all of that stuff starts breaking down. Mostly for reasons we don't know. And when one thing breaks down, you know, I like my arrows. When you tug on one arrow, you move another arrow. And at this stage in the course, that's how you should be thinking. Okay? And I'm trying to think that that's what's wrong on the last midterm. But you weren't really necessarily connecting things. So I want to try to connect everything. So this is the whole course in an hour and 20 minutes, sort of. That's the goal anyway. So we're going to put it together, we're going to tear it all apart. Tearing it apart means aging. We're going to talk briefly about andropause. It's mostly a thing that guys whine about, but it's nothing compared to menopause. And then finally we're going to talk about cancer, which is, in many people's opinion, including mine, a disease of aging. Childhood cancers are fairly rare. People and the animals that we've domesticated get cancer because we all live too long. There's very little cancer in the real world, outside of the world that we've created. So here are the basics that you should know about. We start off with this homeostasis section, talking about the glucostat. Again, I don't know if that's a real word, so. Then we talked about this osmostat, which was used to regulate sodium, but there's no sodium sensor. Your body has no idea how much sodium you have in your blood. But sodium regulates blood pressure, and if blood pressure goes up, blood pressure goes up, angio goes up, which causes aldo to go up. Independent of that, AVP/ADH, goes down. Independent of that, AVP and ADH also go down. Aldosterone does regulate sodium directly, even though it can't sense sodium. And if blood pressure goes down, angio goes up, aldo goes up, AVP/ADH independently go up. So you might even do this. Oops. then you have this independent A and H. That's directly regulated by blood pressure. And ANH is regulating all those other proteins, or all those other hormones, angiotensin, ABP, and aldosterone. In addition, ANH has its own effects on the kidney and regulation of sodium. Oh, that's kind of messy. Then we talk about calcium. Calcium goes up. Calcitonin goes up. Calcitonin is directly regulated by calcium. And in data, there have to be a lot of other arrows. Because not only does PTH stimulate vitamin D, but vitamin D inhibits PTH and itself. We can't put all that in. So you should be thinking about now that all of these homeostatic things, all of these things have to be happening at once. You should be thinking about what are the interactions between your stats. In addition, we've gone through all these axes. So the way you should be thinking is, how are these things interacting? And how are these axes, when they change, for example, at puberty or at pregnancy, how are these impacting all of your homeostatic conditions? We've talked about, for example, that estradiol has several impacts on bone growth. Estradiol stimulates growth hormone, so it stimulates the growth spurt, the linear growth of bone. Estradiol is also very important in both men and women for bone density, the girth, how much calcium is in the bone. Estradiol is also important in stopping your growth. So in the same way it stimulates linear growth, it leads to the calcification of the growth zone and the inhibition of growth. So there are going to be consequences when your reproductive axis doesn't work anymore, which we'll talk about today. We'll talk about it a little bit later. We talked about how thyroid hormone is important for growth. So there's an interaction between the thyroid axis and the growth axis. Cortisol, because it's catabolic on everything, has a really negative impact on growth. And cortisol will impact, actually, let me think before I say this. Yeah, cortisol can impact everything that's on that board. You should know how and where. Cortisol can impact your osmostatic. Cortisol can impact your glucostatic. Cortisol can impact your bone density, your calciostatic, because of its catabolic effects. Cortisol can impact the HPG, the reproductive axis. We talked about that later. Can impact the thyroid axis. Can impact growth. You know that there's several hormones that aren't on the glucostat that have dramatic impacts. Cortisol, thyroid hormone, growth hormone, IGF-1, prolactin. All of those things can interact with the glucostat. We talked about conditions like gestational diabetes, mellitus, where prolactin is not on the glucostat, but it's impacting the glucostat. Cortisol, because of its catabolic effects. We talked about, for example, PCOS. So here you have the HPG for women who have this condition, where their follicles aren't responding, they're making androgens. We talked about how that affects the glucostat. Because those androgens lead to upper body weight, upper body fat, visceral fat, trunk fat, that's associated with insulin resistance. And for whatever reason, nobody understands it, but for whatever reason, insulin acts like a gonadotropin. When it's high, it stimulates those follicles to make even more androgens. So you have an interaction between the HPG and the glucostat. HPG. We're good? We talked about diseases like Addison's disease, where you don't make any cortisol or aldosterone. You should know everything will be impacted by that. We talked about Cushing's disease, where if you're making too much cortisol, again, everything will be impacted by that. All those arrows have to be in line for you to function properly. We're good? Questions? So here's where we're at now. You have all these things that have to be working properly all the time. When you're pregnant, for example, you should not have a higher blood pressure, even though your blood volume is higher. When you're pregnant, you should not have higher glucose, even though now you're making milk and you're making a baby. You have to have that axis functioning and at the same time maintain homeostasis. As you age, however, around about the age 40, and actually the reality is, if you look at developing countries, probably the life expectancy of Homo sapiens is about 40. In many communities, 40 or 50 is life expectancy. So at about 40 or 50, and there are no other animals that, one, delay their reproduction as long as we do, especially you guys going to college and grad school and med school and all that. There are no other animals that go for years wasting, and this is not a social political, it's a biological observation, wasting their reproductive potential, and there are not any wild animals that live way past their reproductive potential. Right? So half of your life is more or less your non-reproductive. Half of your life happens. So as you age, as you reach what probably is your natural lifespan, several of these things start to fail. Several of the axes. So for example, typically, in the growth hormone axis, as you age, growth hormone and IGF-1 in men and women, growth hormone and IGF-1 decrease. I don't know why, nobody knows why. Your growth hormone levels as you get past 40 start to go down. The consequences are, you should be able to look at everything on that board and see what your problems are. Remember, growth hormone, it's lipolytic, it's catalytic on fat. So you're more likely to gain weight as you grow older because your growth hormone is going down. I don't know why it goes down because you're too old. The thyroid axis also starts to fail. So as you get older, your thyroid hormone levels go down. That means that your resting metabolic rate is going down. Again, that means that you're more likely to gain weight, because thyroid hormone is catabolic on fat and carbohydrates, just like growth hormone. So as you grow older, you're more likely to gain weight for those reasons. For whatever reason, I don't know why, the HPA tends to do the opposite. Cortisol tends to be higher as you get older. I don't know why. But again, you can see all of the consequences for having increased cortisol, because you know it interacts with everything on that board. You should know how it affects your likelihood, for example, of getting diabetes. You should know how it affects your muscle tone. You should know how it will affect your intermediate metabolism. You should know how it affects your osmoregulation. And for whatever reason, I don't know why, when the adrenals, as you get older, the adrenals also start to produce typically start to produce more weak androgens. Probably of little consequence in men, but in some women, sometimes you see older women growing like facial hair, and sometimes getting male pattern baldness. That's usually because of an adrenal failure and oversecretion, hypersecretion of androgens, androstenedione and DHEA. And we'll talk specifically about what's happening in men and aging women in relation to androgen. These are just general aging things. There's one more. Oh, the other thing that can happen as you grow older. So typically this happens. Is you have an increase in the likelihood of adenomas. We'll talk more specifically about cancer, but adenomas are not malignant. They're so-called often benign tumors. Benign means friendly. So they're friendly tumors, meaning that, as we'll talk about, they don't spread through your body and typically don't lead to death. But it doesn't mean that they're nice. So you can have, in many cases, adenomas. They're usually glandular. Actually, I think by definition they're glandular. But they can be hormone secreting or non-secreting. So you can develop an adenoma of the adrenal cortex. My dad had one of these. In some cases, they'll secrete cortisol and give you Cushing's disease. We have too much cortisol. In other cases, they're non-secreted. You can have an adenoma of the thyroid gland. A friend of mine's mom just had surgery for this. And it can be secreting or not. In her case, it was a hyper-secreting thyroid hormone adenoma. So a tumor of the thyroid. And you should be able to tell me if you have that. You should be able to tell me everything is impacted on the board. You should be able to tell me if your TSH is going to be high or low. You can develop adenomas in the pituitary. Again, some of them are secreting, some of them aren't. Sometimes they dump everything. Some people, actually I know somebody who had a prolactin secreting adenoma. So at like age 60, she started lactating because she had a tumor that was producing prolactin. You can have a growth hormone producing tumor, like we talked about acromegaly, where it causes your face and hands to grow when you're older. You can have hyperthyroid secretion because of a TSH secreting adenoma. So there are at least two ways that you can develop and the same. You can have a Cushing's disease as a result of an adenoma that's making ACTH. So again, you should be able to tell me what hormone levels would be like in the blood. You should be able to tell me how you would distinguish between an adrenal adenoma and a pituitary adenoma in somebody with Cushing's. You should be able to put all those things together. I've never heard of, people will always say this on the exam, but I've never heard of hypothalamic hypersecreting tumors. I just don't know that they exist. So usually when you have an endocrine problem associated with an adenoma, it's either the end organ or the pituitary. Has anybody ever heard of one from hypothalamus? I've never heard of one. This is I heard of it doesn't mean it exists, right? It doesn't exist. We're good? Now specifically in men, there's this phrase that's been coined, andropause. Happens the consequences are much less significant in men. As I said, the oldest known father is 90, so we're pretty good to go for quite some time. But my granddad had kids till he was like 60 or 70. He was dead, he probably still had kids. In andropause, for whatever reason, the HPG starts to fail. So starting at about age 40, testosterone levels decline. That means that there's some loss in muscle tone. That means that there's some redistribution of fat, because remember how testosterone causes you to store fat. And there are these funny charts that I no longer show in class because I'm not mature enough to do so. But partially associated with blood pressure changes and things like that. That starting at about age 40, right? Because there's more to erectile dysfunction and complete dysfunction. There are these charts that show how the angle of your erection changes with each year. And again, I'm just not mature enough to show you that, so you can look it up on your own. So this starts at about age 40. So it's not, we've talked about with Viagra what complete erectile dysfunction looks like, but you start to, at age 40, lose some of your condition. And oddly enough, the other thing that starts to happen is male pattern baldness. Some of it's genetic. And my dad still has all our hair. My younger brothers started losing theirs when they were like in college. But it's an interesting thing, male pattern baldness. Because even though your testosterone's going down, male pattern baldness is androgen dependent. God. I keep forgetting that other word. Here's something for you to ponder. For whatever reason, the scalp starts to make 5-alpha reductase in men, some men, as you age. Like I said, my dad's 70, he still has all his hair. Depends on the genetics. But for whatever reason, the scalp starts to make 5-alpha reductase. And there are androgen receptors at the hair follicles. And DHT binds to those receptors and causes you to lose your hair. So think about it. Androstenedione is enough to cause you to grow hair in your armpit and your pubic area. Testosterone is usually required for beard growth, and DHT is required for male pattern baldness. But as I said, Asian women can develop it if their adrenal glands are failing and making enough androstenedione. It's very similar to what we talked about in congenital adrenal hyperplasia, right? You can imagine a very similar question coming up. You understand what I'm getting at? So why androgens make hair grow in some places and make it fall out in others? If I knew the answer to that, I'd probably be as rich as the guy who discovered Viagra. But typically what happens now, the reason I drew this up here is we got to talk about it a couple times. So I'm going to draw, remember, if I'm looking at it on paper, that means you don't have to know. So this compound, this synthetic steroid that actually blocks 5-alpha reductase. So typically the treatment is you take this compound to block 5-alpha reductase. The previously marketed product was an anti-androgen that we'll talk about later. But this is the preferred one because it only blocks DHT, and then men still have their androgen, or blocks the production of DHT. So then men still have their testosterone, and they can stop their hair from falling out. It does not, as far as I understand, it does not make you grow new hair. So the hair you've already lost does not come back. I know there's commercials that claim they have products that do that. I don't know anything about that. So it does not make your hair grow back, but it stops more of your hair from falling out. So it stops the male pattern baldness from continuing. Yeah.
So it just blocks the reductase
It blocks the enzyme.
and the scalp.
No, it would do it everywhere. Because in fact, you're going to see in a minute, it's also used in prostate cancer treatment. So it does it everywhere. Actually, no, it's not a pill, it's a pump. No, you rub it on your head, but as it circulates, it goes everywhere. So if you're absorbing it across the skin, so it's probably more localized. Because I think it's a cream, Propecia or something like that. It's called. As you can see, I don't need it if I would know. But I think it's a cream. So it's more local, but it will still go into circulation in the same way that, for example, if you're on a patch for birth control pill, it actually goes into circulation. But I think by applying it locally, you're concentrating it on the head. But definitely if you have prostate cancer, as we'll talk about in a second, it's an oral administration and it circulates. Because that's what you want to do. Any other stuff? So, but keep in mind, again, this is specifically what's happening to your HPG, but all those other things I told you about are also happening. Right? Your growth hormones going down, so your metabolism changing, your thyroid hormones going down, so your metabolism is changing, your cortisol is going up, and your androgens are going down. So you have double reason why your muscle tone is changing. Because remember, cortisol blocks what androgens trying to do. Yeah?
I was wondering if you knew the way that alopecia develops with hair loss.
That I don't know the answer to.
If it's similar or related at all.
Oh, no, I think that's cortisol.
Okay.
So high stress and high cortisol would make, is that what you're talking about?
Yeah.
The stress, yeah, that's cortisol. So cortisol will induce hair loss as well. Probably just because it's general catabolic effects on the follicles and the growth. But that's not because here. But older women will get male pattern baldness again because of the adrenal androgens. Not because of this. Because they have a lot of androstenedione can do the same thing as a little bit of DHT. So we already talked a little bit, and sperm count, fertility goes down. And decreased muscle tone. So again, fertility is not going down in the same way it does in menopause, but in general, your sperm count goes down, decreases. But it's nothing like in menopause, where your fertility essentially goes to zero, where you simply stop ovulating. So we already talked about menopause. I want to go over it one more time. And again, when we talk about menopause, or the loss of reproductive capability in women, just like at puberty, it's a lot more obvious. So if there really is an andropause that happens in men, it's not some abrupt moment where, all of a sudden you have no testosterone and no sperm. Whereas when women completely reach menopause, it's pretty clear. When you stop having what menopause means, you stop having your menstrual period, you stop ovulating, and there's a complete loss of fertility. It's associated with increased GnRH pulse frequency, because there's decreased progesterone and estrogen. Because the ovary follicles simply stop responding. It's not because you run out of eggs. The follicles simply stop responding for some reason. It's not related to menarche. So in other words, if you start your period early, you won't have earlier menopause. There's no relationship. It's not related to whether or not you're on the pill. Like somebody always asks, if you take the pill for 40 years, can you go off the pill and then have like another good 20 years? And it doesn't work that way. So if you never ovulate, so it's not related to how many times you ovulate. So if you're on the pill all of your life, you have not prolonged your reproductive life. There's no relationship. How many times you're pregnant, there doesn't seem to be a relationship. The ovarian follicles simply stop responding. As a result, there's low inhibin, increased FSH, increased LH, and I'm not going to rewrite it. Everything is associated with that, physiologically. The hot flashes, which again are thought to be kind of estrogen withdrawal, loss in bone density, osteoporosis. So even though you still have vitamin D, even though you're still taking calcium, estrogen's not there to induce the osteoprotegrin, to induce the facile, to decrease the wrinkle, to increase caspase, and the osteoclast. Estrogen's not there to do that, so you lose calcium from the bone. In addition, there's a loss of libido, there's a loss in uterine weight, loss in breast size. You're no longer stimulating the breast, there's no longer estrogen. And what did we talk about? Atherosclerosis. So there's an increase in the risk of atherosclerosis. And so atherosclerosis, I'm not going to try to spell it. Atherosclerosis is typically higher in men. I just looked this up today because I know the answer. And what it is the cells, the epithelial cells in your blood vessels tend to accumulate fat over time as you're getting older, especially if you have a high fat, high cholesterol diet. So the epithelial cells start to accumulate fat and cholesterol, and they create these plaques in your artery. And as a result, the arteries actually initially get larger, but as a result of the thickening of the wall, the arteries get smaller, so there's less space for the blood to flow through. And in late stage plaques, they take up calcium. And so remember how the blood vessels have this muscle layer around an endothelial layer? And these late stage plaques, they've taken up calcium so that they can't expand and contract the way that they used to. So it generates problems with blood pressure. So women are generally protected from that, but after menopause, because what estrogen does apparently is it stops the liver, or it decreases the liver releasing these cholesterol esters, which are then the things that form these plaques in the arteries. So estrogen has some effect on the liver where you release less of these cholesterol esters. So you're less likely to have atherosclerosis. After you reach menopause, your risk starts approaching that of a male. In addition, as I said before, keep in mind that in addition to menopause, all those other things we talked about with aging, all those other things we talked about with aging are also happening. So not only has your estrogen gone down, so your risk of atherosclerosis is going up, but also your growth hormone is going down. Your cortisol is going up. Your thyroid hormone is going down. So you're more likely to gain weight. And as the adrenal fails, you start making more and more androstenedione and DHEA. So you start accumulating fat in a more masculine fashion, which now increases your risk of type 2 diabetes. Because you're changing how the fat's distributed about your body. Yes?
The weak androgens that are released, can those help rescue your bone or your libido?
I have never heard that. One would guess, but I've never heard that that's the case. Other question? I guess that's because mostly people focus on is on the negative aspects of having low estrogen and higher androgens that are causing a difference in fat accumulation. So it probably outweighs the rescue of the bone, I would guess, the negative impact. Other stuff? Yes?
You said it also increases thyroid hormone levels, and that's why it causes.
As you age, thyroid hormone levels go down. The thyroid axis starts to fail. I don't know why, because we're too old. So as you age, your thyroid hormones tend to be lower. And remember this, it's also coordinated with lifestyle, right? As you're getting like 50, 60, you're probably less active as well. But there are definitely endocrine reasons why your metabolism and your body type changes as you get older. In severe osteoporosis, you even change size. You start to shrink as your spinal column starts to collapse.
So these things, like, all this typically happens regardless of whether you lead like healthy lifestyle.
No, that's not true. So if you stay physically active, if you follow good nutrition, I mean, yeah, they're eventually going to happen.
Yeah.
But I know, I bike home. Sometimes there's like 60-year-old guys biking past me. So a lot of it depends, especially bone health, for example. Apparently, the really important thing is that you have calcium and vitamin D in your diet early. So after menopause, trying to do that apparently has very little impact. And it's because of all those things that estrogen was doing to the osteoblasts and inhibiting the osteoclasts. Even if you get the calcium now, you simply can't lay it down. So if you start off with low bone density, you're not as well off. If you start out, for example, overweight, and then these things start to happen. I can tell you now, somebody who lost 140 pounds at age 30 and who's now lost 55 pounds at age almost 50, it's a big difference, right? Metabolism changes, muscle tone's changing. So the better you start out, when you get there, the better off you are. But yeah, you still age. Peak pan. All right, we're good? Okay. The other thing that we have to talk about that's associated with aging is cancer. My colleague Gary Firestone says everybody would eventually get cancer if you live long enough. So I think the number one cause of death is heart disease, and after that's cancer. I think it was lung cancer, but the two main cancers now are prostate cancer and breast cancer in men and women. Although some men actually, my academic grandfather died of breast cancer. So men do get breast cancer, but it's much worse. So cancer literally means crab, and it's because the growing cancers were thought to look like crabs when people first described them. So that's where the name comes from. As I said before, you can have benign tumors. Those are friendly tumors, tumors that don't spread. Doesn't necessarily mean they're literally friendly. As I said, they could be secreting hormones or secreting other compounds that impact your health and your physiology. A malignant tumor, malignant means like bad or harmful. These are tumors that are usually of ectoderm or endoderm derivation. So they're derived from ectoderm or endodermal cells. And malignant means that they can spread. You die, for example, from breast cancer, not because you have a cancer growing in your breast, but because that cancer spreads and can grow in your spine or your heart or your brain. In that case, you can't survive. Cancer itself is uncontrolled or unchecked growth of cells. So typically cells have a lifespan and they undergo something called apoptosis. It's a controlled cell death. It's a very specific thing, apoptosis. Cancer cells have uncontrolled growth. They typically don't undergo apoptosis. And they don't have something called contact inhibition, whereas normal cells, when they bump into other cells, will stop growing. Cancer cells will start growing all on top of each other. So it's uncontrolled or unchecked growth. Childhood cancers are fairly rare. So in my opinion, and I think Gary would agree, cancer is more or less a disease of aging. I said we live too long. And it's the accumulation of the salts on the cell. That's one way to think of it. So the longer you live, or the more cancer-inducing agents, we'll talk about some of those are, the more likely you are to develop cancer. Things that can be damaging are like ionizing radiation can cause DNA damage. UV light, UV radiation. So the same way there was selection for lighter skin as people moved north because of vitamin D, there was selection for darker skin around the equator to block UV light. Because UV light causes pyrimidine dimers, which damage DNA. There are chemicals that are carcinogens. Carcinogen means the generator of cancer. So if you're younger and you're exposed to chemical assaults, to radiation, there's also some viruses involved, so sometimes viral genes can induce the cancer. If you're exposed to more of these things, then you'll get cancer earlier on. But again, as Gary says, if you live long enough, we'll all get it. Your cells can't go on forever. The relationship to endocrinology is that the top two cancers and a third are hormone dependent. Breast cancer and prostate cancer are both typically hormone dependent, not always, although again, my colleague Gary Firestone says probably all breast cancers are estrogen dependent. Some of them lose their estrogen sensitivity, but 70% of breast cancers, I think is the right number. Correct me if I'm wrong, 70% of breast cancers are estrogen dependent. And Gary says probably they all start that way because the breast cells are responsive to estrogen. It's not necessarily the estrogen that causes the breast cancer, but it promotes it. We'll talk about it later. Although there's at least one line of research that suggests that estrogen can be both an inducer and a promoter. So an inducer is something that causes the damage. And typically, I think you can't just have like one mutated gene and get cancer. You typically have to have multiple assaults, so multiple protections against the cell. So usually some combination of damage or mutated genes and assaults that end up inducing or causing the cancer. Then there are promoters